let's do some exponential decay practice. So we're going to start with a $22,000 car depreciating by 12% a year. Well, if 12% is 0.12, so if you have 1 and you take away depreciate means go down, that means our decay factor is going to be 0.88 because that's how much is still there. So our model, y equals 22,000 times our decay factor raised to the amount of time, right, t years after. So there's my model. Now, how much will the car be worth in 4 years? So that means t equals 4. So y equals 22,000 times 0.88 to the t. I'm going to plug in 4 for t. Remember, you do your exponential first, then multiply by 22,000. And after 4 years, your $22,000 car is worth $13,193.30. Now, that just assumes normal wear and tear. If you put it into a tree and have it rebuilt, or your alternator's going out, or blah, 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 that could alter things. Or if you don't drive it at all, it might have better value. So, of course, right, that's on average. Let's go with number 2. High-definition TVs are averaging $1,500 currently, but costs are decreasing at a rate of 15%. So that means my decay factor is 0.85. How many years will it take for these TVs to be half of the original cost? So my formula, 1,500 times 0.85 to the t. And we want to know what is t. We want y to be half of that, half of 750. So what is the value for t that'll get this to be 750? Well, I don't know. Let's guess. So if I plug in 4, so 1,500 times 0.85 to the 4th power, so when t equals 4, I have a y value of approximately $783. Well, that is not 750, right? That's too far above. That doesn't work. So let's try 5. 1,500 times 0.85 to the 5th. So when t is 5, my y value is 665, and that is lower than half. So it's going to be somewhere between 4 and 5 years. If you want just a solid year, then you would say approximately 5 years. Because at 4 years, you're not down to half, you're still above half. So you got to go all the way. All right, let's do one more problem here. Most cars decrease in value as soon as you drive off the lot. However, some cars are now considered classics, and therefore they increase in value over time. So we've got a Mazda Miata, which sells for $23,000 but is depreciating. It's going down by 10% a year. And then we have a Ford Mustang, which is worth $12,000 right now, but it's increasing in value because it's a classic. So first things first, let's write the equations for each car. All right, so for the Mazda, I'm going to do it on this page because I think it'll be easier. The original price of the Mazda is $23,000. It's depreciating. That's 1 minus 0.1, so my decay factor is 0.9, raised to however many years we're talking about. Now, the classic Ford starts at $12,000, but it's increasing, so we're at 1 plus 0.06, so we're at 1.06 raised to the t. And these are my 2 formulas that I'm going to be playing with in this here problem. Okay, so we're going to use each equation to estimate the value of each car over the next 6 years. Meaning, for the Mazda, I'm going to do 6 years. So y equals 23,000 times 0.9 to the first. I'm going to do y equals 23,000 times 0.9 to the second. I'm going to do 23,000 times 0.9 to the third. I'm going to do this for 6 years, find my answers. Then I'm going to do the same thing for the Ford on this page, right? Y equals 12,000 times 1.06 to the first. Y equals 12,000 times 1.06 to the second. For 6 years and find answers. I want you to hit pause and try this. Get those values for the 6 years for each problem. Then come back and check your answers. All right, so for the Mazda, you get your 6 years, and you can see it goes down, right? 10% each year is what it decreases. And you go to your Ford, and it increases, right? 6% each year, so just a little bit increases. So at what point in time will the value of the Ford exceed the value of the Mustang? Well, I have these side by, it's hard to see when they're not side by side, but in year 4, the Mazda Miata is worth $15,090.30, while the Ford is worth $15,149.72. So it's at year 4 where the Ford takes over value from the Mazda and then just continues on from there, right? Because every year that gap will get larger. And that is the end of the practice video in comparing between exponential growth and exponential decay. Obviously, growth goes up, decay goes down, and whoop-dee-doo.